We've spoken of many properties of water. For example, the fact that the density of the solid is less than the density of the liquid. This means ice floats. This is very important because ice float then forms on the surface of the liquid water, on tops of lakes and ponds. This saves the fish beneath it, adds an insulating layer. Now, it also means that larger bodies of water that are very deep and so very cold and away from the sun, like the oceans and the lakes, don't permanently freeze at the bottom. We also said that we have a fabulous solvating material in water, that so many things will dissolve in water. This means that it is very rare to find water that is drinkable. 97.4% of the water on Earth is in the oceans, and it is saline and it is unpotable. There's a lot of it in ice caps, glaciers. In fact, 2% of that number 2.5 right here, 2% is solid. Yeah, it might be floating, but whoop-de-doo, we still can't use it. So approximately 6.6% or 5.9 is available as liquid water and fresh without salt in it. Lakes, rivers, atmosphere, soil moisture, about 0.01%. Well, we take water, though, in the United States at least, for granted. We need about half a gallon or 2 liters of water per day to survive. In average, though, the person in the United States consumes about 75 or 300 liters a day. Okay, about 2 gallons per person for cooking and drinking, and 30 gallons for cleaning, 20 gallons for flushing toilets, and on average 20 gallons for your lawn. Where does all this water come from? Well, we've got surface water, which is self-explanatory, and then something called aquifers. And these are pools of water underground. We have a lot of good sources of water in North America, and our water is incredibly cheap in the U.S. It is about 1/10 of a penny per quart. Very inexpensive. Now, right in the center here is something called the Ogallala Aquifer. Look how big he is. He encompasses 800 miles north-south, 400 miles east-west, and 95% of this water goes for irrigation. Pumped out, goes for irrigation. That is growing crops. Now, as you might imagine, surface water usually has a lot of pollutants. Groundwater has few. It's funny that people are buying so much bottled water these days. Worldwide, $40 billion per year is spent. In this country, $80 billion. Folks 18 to 24 are the major consumers, especially those pint-sized bottles. And since tap water costs 0.001 per quart, bottled water, you compare that to bottled water, it's about 1,000 times more expensive at about $1 per quart. Where does OSU get its water from? Basically, the Hoover Reservoir and the Olentangy watershed, which is aquifers and rivers and streams and tributaries all put in together. Well, our water is never pure H2O. If you look at Avion, the thing that started it all, with bottled water, you can see these are the ions now. Calcium, magnesium, silica is silicon and oxygen together. Bicarbonates we saw before, that's a lot there. Sulfates, chlorides, nitrates. A major reason we much consume water is that it's an excellent solvent for many of the chemicals that make up our bodies, as well as a variety of other substances. So we do need these electrolytes. Mineral water, this is tap water. This is the how much these things are all called together minerals. These different uh, dissolved ions. Okay, there's calcium, magnesium, sodium. Sodium is good for us in small amounts, bad for us in in high amounts. Sulfate, chloride, nitrate, and fluoride. Okay. The oceans. This is a map of the Pacific Ocean. You can see South America here, North America here, Central America, and Australia. All right. The darker it is, the more salt. And this is grams, greater amount of sodium chloride dissolved. And this is grams per 100 grams of water. This is in grams, I believe, per 1,000 grams. Yeah, 1,000 grams of H2O. All right. And you can see that it varies quite a lot in the oceans. Over here, it's much less because it's got water flowing into it, fresh water from streams. And here, it's much higher because of evaporation and no pure water influx or freshwater influx. A huge number of people in the world do not have access to fresh water or easy access to potable water. More than 1 billion. That's about 1 out of 6. Don't have, let's say, ready access. That means they probably can walk many miles to get it. Potable means drinkable. Potable means drinkable. One estimate says it would cost $68 billion over the next 10 years to provide safe water and decent sanitation to everyone in the world. Especially at risk are children and infants. Now, if you've got money, you can produce potable fresh water from seawater. For example, in Saudi Arabia, in Florida, they will do things, for example, like distill it in small quantities. This is feasible. You boil it and the salt stays down here, the sodium chloride ions stay up here, and what we have is H2O gas. And then this is cold water, it cools it and drips out. This is pure H2O. The other way is reverse osmosis. This is how most bottled water is purified. They'll have a membrane that only allows H2O molecules through, usually by size. And adding salt water and high pressure, the brine, which is another word for saline, which is another word for salt water, gets more concentrated up in this chamber, and pure water comes out the bottom chamber. A lot of energy. This requires a lot of energy. And in places like Saudi Arabia or the Middle East, where oil may be cheaper than water, this is very common. And Florida has over 100 reverse osmosis desalination facilities. And as I said, this is the way bottled water is purified.